All right, so let's very quickly try de Moivre's with n is 2. Okay, so I'm going to write e to the I theta squared should be what?
That should be ei to the 2 theta.
So that should be cosine theta plus I sine theta squared, right? Which should also be, on the other hand, e to the I 2 theta. You guys with me? And that I can plug in and get what?
Cosine 2 theta plus I sine 2 theta.
Okay. Okay, so these are going to tell me about double angles, right? This thing is going to be the tool I use to do that. You guys with me? So de Moivre's is really that this thing has to be that thing. So I want to FOIL this guy out. So I'm going to just take that off to the side here. And I got cosine of theta, oops, plus I sine of theta. And I need to square this sucker. So really I need to write it down twice. And FOIL.
You get cosine squared plus cosine times I sine theta.
Hang on. Cosine theta, I sine theta.
And that's multiplied by 2 because it happens again, and then you have negative sine theta.
Perfect. You guys all see why I've got negative sine theta?
Squared. Yep.
Cool. So this term, right, the last term, should be I sine theta times I sine theta. So there's a sine squared and an I times an I.
Which means it's a negative 1.
Which means there's a negative 1.
Okay.
And I would have been adding this, so I'm just going to subtract it. You guys cool with that? Okay, so now what?
Wait, wouldn't it be just negative sine theta then instead of squared?
Okay, so this was I squared times sine squared theta, right?
Okay, that makes sense. I don't know.
Can you pull some ones and stuff out of there? Or make them the same?
Close. Pulse.
That's the Pythagorean identity.
Okay, so there's a false Pythagorean identity here. Thank you for pointing that out. Why is it false and not actually the Pythagorean identity?
Because it's a negative?
Because you have cosine squared minus sine squared, right? And the Pythagorean theorem is, or the Pythagorean identity is cosine squared plus sine squared, right? So here's what you can say, though. What you can say is the bits without i's, right? Cosine 2 theta has to be the bits without i's down here. You guys with me on that? So I can write down cosine squared of theta. Wait, not cosine squared of theta. Cosine of 2 theta, right, is what? Cosine squared theta minus sine squared theta. That's one of those double angle identities. Cool. And where's the other one? So what's the other bits tell you?
Sine squared theta.
I sine squared, or I sine of 2 something.
Okay, so sine of 2 theta, right? That's this guy here. And I left off the I. Has to be
2 cosine theta sine theta.
2 cosine theta sine theta. That's this bit here, where I also left the I out.
Why did you leave the i's?
Why did I leave the i's out? So that's marking which coordinate this is, right? And miracle of frickin' miracles, you can actually divide by that vector I.
Okay. Oh, because there's an I on both sides. You can divide it and it onesies out. Okay.
Yeah,
Cool.
it should be noted that that is actually a miracle. You cannot, in any other reasonable vector space, divide by vectors. That only makes sense in the complex numbers and is actually a miracle. Okay? There are not many things I'm telling you are magic. The reason for why you can divide by I is pretty easy. Like, we made it in a way that makes it reasonable to divide by it. But the fact that it's a vector space makes that extremely remarkable. There's a very deep theorem that says that this is the only vector space where that kind of operation is reasonable. Cool? All right, so out of de Moivre's for n is 2, we managed the double angle identities. Where would you get the triple angle identities if you wanted them? Yeah. Do de Moivre's for n is 3, gather the real parts up, gather the imaginary parts up. You'll get two things. One will be for cosine of 3 theta, the other one will be for sine of 3 theta. You guys cool with that? If you wanted the 27 angle, I don't even know how to say this. Whatever you'd get for an identity with 27 times theta, right? You'd plug it in n is 27 and you'd spend all day multiplying it out, and then you'd equate the real part and the imaginary part, you'd be good to go. You'd have made an arithmetic mistake, so you'd have to throw it all away later, but whatever. Cool? Questions, Steels? All right.